In this video we are going to discuss the convolution part. So just take the LTI system. This is the linear time invariant system. Okay, this is the linear time invariant, and all the part of the convolution is totally related only with the linear time invariant system, LTI system. That is, the system should be linear time invariant. That is, it should be invariant with respect to time. Right now, so if you see the block diagram of any LTI system, just give the xt as an input, take yt as an output, and ht is the impulse response of the system. This one is the impulse response of the system. ht is the impulse response of system. Okay. Now simply the output of linear time invariant system is depend upon the convolution of input and the input xt and the impulse response of the system ht. So the main thing of the convolution is yt is equals to xt convolution of ht. Right. This is the convolution in time domain. Right. Now, what is the physical meaning of this convolution? So if you see, this is simply, just see, this is the xt, one signal in time domain, ht is again a one signal in the time domain, right? So relation of convolution between xt and ht is given as minus, it is just an integral of xt and the time shifted version of ht. So x tau h t minus of tau and d tau, right? And where the limit of tau are minus infinite to infinite. So what is the physical meaning of convolution? It is just a integral of xt with shifted version of ht. That is, we have to find out the area of this particular part, right? Now come to main point. Yt is equals to xt convolution of ht, right? So all the transform of, then if you have to take the transform, right, all the transform of yt, xt and ht are just assume as a y omega, this is the Fourier transform, x omega Fourier transform, h omega Fourier transform, and ys is equals to xs hs. This is for the Laplace transform. This is the Laplace transform and this one is the Fourier transform, right? So this is the transform of the convolution. So we can say that the transform of any convolution function, the transform of any convolution is always equals to the separate product of their transforms. If you see, we have to find out the Laplace transform of that particular convolution will always be equals to separate product of the Laplace transform of xt and ht. Ys is equals to xs into hs. Most important thing, right? Now, this is in the time domain. This is in the time domain. And this is in the frequency domain. So, transform is always defined in the frequency domain, right? So we can say that this is the LTI system. LTI system yt is equals to xt convolution of ht, that is minus infinity to infinity x tau, ht minus tau and d tau. And in the transform form, ys is equals to xs into hs. So we can say that this hs is equals to ys upon xs. That means this hs is the transfer function of system. Transfer function of system. So we can say that transfer function of any system is defined as output of Laplace transform of or any transform of the output divided by any transform of the input ys upon xs. This is the transfer function. We can get this by using the LTI and the convolution. Okay, so that was the overall relation between the convolution, LTI system and the transfer function, right? So next part is some important formulas are there. If you see x1, or just take it as x, t plus t1, convolution of del t plus t2 is always equals to same x t plus t1 plus t2. Okay. Also x t plus t1 convolution with u t plus t2 is always equals to integral of x t plus t1 plus t2, and dt will be there. So for solving any type of problem, you can use this particular formula, that is the convolution of any function with del t will remain the same function but in the separate form of the both the x and del t. Also, if we take the convolution of any function with respect to ut, that is a unit step function, then it will be the integral of that function. Okay, integral of that function by shifted amount t1 plus t2. So the most basic concept is, if we take the integral of del t, we will get the ut. Now when we take the integral of ut, then you will get the ramp t. When you will take the integral of ramp t, then you will get the parabola of t. Also, the reverse of this, when you take the differentiation of parabola of t, then you will get the ramp. When take the differentiation of ramp signal, then you will get the unit step signal, and when you take the differentiation of unit step signal, then you will get the del t signal. This one is the most important part for solving the problems related to the convolutions, right? So, if we are doing convolution, it is just an example. If we have to find out the value of x t plus 1 convolution of del t plus 2, or just take it as a minus 2, right? Then what will be the value of x t plus 1 convolution of del t minus of 2? So there is a two methods. You can use directly a formula, that is this one, x t plus t1 plus t2, that is the formula number first here, this one. Okay, you can directly apply this x t plus t1. So if you see, this is 1, this is minus 2, that will be the minus of 1. Okay, this is the direct formula. And now you can also apply the transform method. So if you have to find out the value of this particular part, then take the transform of this part. I am using here a Laplace transform, right? So what is the Laplace transform of any convolution function? It is just the separate product of their Laplace transform of the particular functions. So the Laplace transform of xt plus 1 is always xs multiplied by e power of omega s. That is, omega is 1, so it will be minus 1s multiplied by del t minus of 2, so it is the 1 and e power of 2 of s. Okay, so when we solve this one, then you will get xs multiplied by e power of minus of s, right? So whenever inverse transform, then when you take the inverse transform of this part, then xs is xt only, right? And this is the separate part, that will be t minus of 1, x t minus of 1. So this is the two method. First one is the direct formula, this one. Also you make a derivation of this formula by using this concept. Okay, so this is the first part and this is the second part. Also, or you can say that if in graphical way, what is the xt plus 1? Just assume any xt as a, this is just any function xt. Okay, this is any function xt from 1, 2 and 3. This is the t, and you have to convert this with the del t minus of 2. Del t minus of 2, that means it is the del t, and minus of 2, that means this is the t is equals to 2. Del is available, delta function is available at t is equals to 2. Okay, so if we have to perform this operation, then the result you will get will be the x t minus of 1. T minus of 1, that means this time it is at the 0, so t minus of 1, so it will be shifted by a right side by 1 unit, so that will be, it is 1, it is 2, it is 3 and it is 4, so it become 2, 3, 4 and height is 1 and 2, so height will be 1 and 2, right? So that will be the xt minus 1. So physically if you see the graph, then what is going here, if we have to take the convolution of this and this, you will get this, just a shifting part, that is the because of the del t, right? Same way, you have to perform any convolution by using this and this. So just take again one example. If we have to find out the convolution, or just take, not take as a ut, some other function, just x t plus t1, t plus 2, and some other function is as a convolution of this with respect to x t plus of 3. So this time we have to find out the value of xt plus 2 convolution of xt plus 3. So first thing is you have to find out the transform, main thing. You have to find out the Fourier or Laplace, anything. So here I am taking the Laplace transform LT. So you will get, this is xt plus 2, then it is the xs, and e power minus of 2s multiplied by xs e power of minus 3 of s, right? So when you combine, you will get xs e power of minus 5 of s. So now the convolution was asked in the form of in time domain, right? Now we are solving in the frequency domain. So we have to shift from frequency domain to time domain by using the inverse Laplace transform. So it is the inverse Laplace transform by taking. So the inverse Laplace transform of xs will be xt. Okay, and there is a shifting of minus of 5, that will be the x plus 5. So this is your answer. Okay. So that is the physical meaning of the convolution. So most important properties for the convolution related problem is this one and this one. Okay, thank you.